The fourth reason for children to develop fear for math is a very precise subject. There's a huge demotivating factor associated to math. I remember my niece. She was doing a math homework and she was getting all her sums right. I asked her, "Come, let's go and play." She said, "No, I'm doing math." She was excited. After some time, she got a wrong answer and she got demotivated. She closed the book and did not open unless we forced her to open it again. How much ever we motivate a child, it may or may not lead to success. But on the other hand, if we make a child feel successful, they naturally get motivated to do more. And that's the mantra. Make a child feel successful in math and they get prepared to face all challenges. Like statement made to children like, "How many times should I explain? Can you not understand? Can you not focus?" distances a child from becoming friends with math. Especially when it comes to elementary education, children should feel successful learning math, not stressed. Keep tuned in to see my next video. Signing off, Jay, your math friend.
Patterns and sequences are one of the many important concepts in math. Hello everyone, today we have Ananya, a 4th grader from Little River Elementary School. So, what will you be talking about today?
Hello viewers, one of the major concepts in math is patterns and sequencing. Today I will be talking about a very interesting pattern called Pascal's triangle. Pascal's triangle is a very interesting number pattern that is named after Blaise Pascal, who is a very famous and is a French mathematician and philosopher. To make the triangle, you place a number 1 at the top and then you continue placing numbers below in a triangular pattern. Each addend, if you look at the 2 numbers on top of it, if you add them together, they will make that number. For example, 3 plus 3 equals 6. 35 plus 35 is 70. And 5 plus 10 is 15. Can you see a palindrome? A palindrome is when you see one, like here's an example, 1331 can be read from backwards and it'll be the same number, 1331. And also another example, 17, 21, 35, 35, 21, 7, 1. 1, 7, 21, 35, 35, 21, 7, and 1. Let us see a few interesting patterns in this Pascal triangle. The first pattern is, you can see the palindrome, which I just showed you. The second pattern is patterns observed in the horizontal rows. A, sum of horizontal digits. Like row 0 is equal to 1, which is equal to 2 to the power of 0. Row 1 is equal to 1 plus 1, which is equal to 2 to the power of 1. Row 2 is equal to 1 plus 2 plus 1 is equal to 4 is equal to 2 in the power of 2. Row 3 equals to 1 plus 3 plus 3 plus 1, which is equal to 8, equals to 2 to the power of 3. And third, polynomials. Pascal's triangle can also show you the coefficients of the binomial expansion. Row 2, binomial expansion is x plus 1 squared is equal to 1x squared plus 2x plus 1. In the Pascal's triangle, it's just 1, 2, and 1. The row 3 is the binomial expansion for row 3 is x plus 1 cubed is equal to 1x cubed plus 3x squared plus 3x plus 1. In the Pascal's triangle, it's 1, 3, 3, 1. Cool, isn't it?
It really is. So on all of your behalf, I thank Ananya for explaining such a cool pattern, such as the Pascal's triangle.
Thank you all, and thank you, Isha.
You're welcome. Wow, what a mathematician that Blaise Pascal was, and what a triangle he created. Thank you so much for watching, and we hope you enjoyed as much as we did. We'll see you soon with some more math concepts that lie ahead. This is Isha Patel, signing off. Did you know Americans called mathematics math, arguing that mathematics functions as a singular noun, so math should always be singular too. They always have their own way out. To keep you updated with our new programs and services, and to subscribe to our email list, click on the link below to fill out an easy form. And make sure to like, follow, and subscribe to Channel N.